So you had this worksheet, and we've gone over several examples. And on the back side, on the 7.7 side, there is this word problem that we really need to understand and be able to do. So it involves a formula, and they give you the formula, just like on the final, they'll give you the formula. But it's an investing question on annually compounded continuously, right? So let's read this and understand it. Sarita deposits $1,000 in an account paying 3.4% annual interest compounded continuously. Use the formula for continuously compounded interest, which is A equals P times E to the RT, where P is the principal. What does principal mean? It's the initial amount of money that they're using to open up the account. Okay, so this value is going to be P, the principal. E is that irrational value, kind of like pi. It's located on your scientific calculators. E is really 2.72, and it continues forever. But that's the E button. The R is the rate, which we're talking about, the annual percentage interest rate. And T, it represents time. Okay, and that's what it kind of explains here. Okay, so they first want us to find out what the balance is in Sarita's account after 5 years, after 5 years pass by. So let's set up the equation. First of all, what's her principal balance? What does she go in and start working on? How much money does she have when she started? $1,000. Okay, so when we say that the formula reads A, the answer, the amount, is calculated by taking your $1,000, the principal balance, and then multiplying it by E, which is the E button on the calculator. But on the power of E, you have the rate, which is, this R is 3.4%. But when you use it in the formula, you have to change your percent to a decimal, and that requires you to move the decimal place over 2 spaces. So that would be a 0.034. The percent, 3.4 as a decimal. Again, this was a 3.4. We're going to move that decimal 1, so it'd be a 0.34, and then another, so it'd be a 0.034. So there it is, 0.034. I guess you don't have to put the 0 in the front, but the 3.4% is really 0.034. Is that clear to everybody? So on the exponent of E, it might be safer to open up some parentheses and put that 3.4% as a decimal, 0.034, and we still need to multiply it times time. Okay? Now, this question is asking, what will her amount, her balance be if she initially started with $1,000 principal at that rate after 5 years? So times time is going to be multiplying by 5. So this is the formula in action, given the information provided. Any questions on that so far? No? Okay, so from there, we're going to use the calculator. And on the calculator, I just did 0.034 times 5, and that gave me a 0.17. So what we really have here is 1,000 times E to the power of 0.17. And with the calculator, $1,185.30, because the 4 doesn't round it up to a 31 cents. But anyways, I guess it's important right now to show you where the E button is at. So if you look for it on the Casio calculator, you're not going to easily find it. But you need to understand that E is the inverse of, or E to the power is really the inverse of ln. So if you look at the ln button, right above the ln button in orange or yellow, whatever that is, it says E to the blank, right? So in order to get that E button, you're going to have to hit Shift and then LN. So if you hit Shift and LN, it'll automatically put that E right there with a spot for you to type in your power. So anyway, the formula was A equals the principal, which was 1,000, times E, which is the E button, shift ln, and then up here on the power, if you wanted to, you could have actually typed in the rate times time and let the calculator do the whole thing. You should get the same answer anyway. I did rate times time on my own, got 0.17, and then I plugged it in, and we got this as a final answer. So after 5 years, she will have $1,185.30. Now, if this 4 would have been a 5, then it would have caused that 0 to go up to 31 cents. But it's not. So $1,185.30. That is how much money she will have after 5 years. Does that make sense? Any questions on that? It's pretty straightforward. They give you the formula. So once again, let me go back to the formula itself. They give it to you right there. They tell you the amount is going to be your principal amount. The principal is 1,000 in this case. I mean, you might start with 5,000 on a different question, or 500 on a different question. Right here, she started with $1,000. E is the E button, and it's the power of R times T, rate times time. But you got to remember that rate, you want it as a decimal. Okay, because they provide it to you as a percent, which means that you got to move it 2 spaces over. So it was a 3.4%, but that point got moved over 2 spaces, so it became 0.034, no more percent. So you write it as a decimal. And then times time times the 5 years that they tell us. So I hope that makes sense. After 5 years, her $1,000 becomes a whopping $1,185.30. So she only made $185.30 after leaving her money in the savings account for 5 years. Doesn't sound like much, huh? Next part of the question is, how long will it take the balance in Sarita's account to reach 2,000, for it to double, right? So how many years would she have to leave it in this account that pays 3.4%? Compounded annually, continuously? How long would it take for it to double to be 2,000? So what we're going to do is write an equation using the formula, but this time they're asking how long will it take? So the question is time. How much will time be in order for your answer to be 2,000? So let's write the formula one more time. It's the amount is going to be your principal times the E button to the power of R times T, rate times time, okay? So in this case, they're asking, how long will it take? We don't know time. So that's going to be our variable. We could put it as X, but I'm going to leave it as T. How long will it take for the amount to become 2,000? So you're going to put 2,000 on the A spot equals, she started with $1,000, so that's your principal balance, times E, which is the E button, to the power of rate times time. Now the rate is the same rate, which was 3.4%, and that percent as a decimal was 0.034. That's a 3.4% as a decimal, 0.034. And we're going to multiply that by time, which we don't know. Time is years. Okay, and that's a question they're asking, how many years? So how much time? So we want to solve this equation for this missing variable t. The problem is, how do we solve an equation? We get the variable by itself on one side, so we need to eliminate everything. So I need to think about getting t by itself. What's the first thing I could do to get t by itself? Something that's fairly easy. I mean, some of us are thinking t is in the exponent position. We're going to have to apply a logarithm to bring that down. Yeah, that's true. But is there something... Yeah, if we could get rid of this 1,000, right? Now, if it would say 1,000 plus this, then you would subtract 1,000. But it says 1,000 times this. So I'm going to divide by 1,000. Divide by 1,000. Cancels out. Divide by 1,000. 2,000 divided by 1,000, that's just 2. 2 equals e to the 0.034t. And now we want to bring that exponent to become a regular term. We don't want the t as an exponent. So how do we undo an exponent situation? With the logarithm. In this case, log base e, thank you very much, which is technically ln. So hopefully by now you're comfortable with ln, which is really log base e. I mean, you could write log base e here and log base e there. I'm just going to write ln because that's what we need to do anyway. So ln of e, that eliminates. We're going to have the exponent that drops down as a regular term now, 0.034t equals ln of 2. So for my final step, I'd have to do what to get rid of that 0.034 in front of the t, which is being multiplied? I'm going to divide 0.034. That cancels it out, divide by 0.034. And that'll give you your answer to t, all right? So give me 1 second. Let's get some more space here. So there it is. I typed in ln of 2, and I hit equal, and it gave me that crazy decimal answer, all right? So ln of 2 is this crazy decimal, and I still need to divide this crazy decimal by 0.034. So all I have to do now is hit the divided by 0.034. So we end up with 20.38. So the bottom line is, how long will it take for her $1,000 to become $2,000? A little over 20 years. That's sad, huh? So I would say like 20.4 years. Almost 20 and a half years. Dang. It's horrible. Anyway, that's how you do these types of problems, and I believe there are these types of problems on the final exam, at least one of them.